Find the polar coordinates of a point whose rectangular coordinates are 0, comma 3. Let's just look at the graph. The rectangular coordinates, so this is x comma y, and that means that x is 0 and y is 3. 2, 3, right here. And this is not too hard because it's right on my axis. I know that if I'm going to put it into r comma theta, this is easy to see that my radius is 3, right? This is my radius. Because I could draw a circle at that point. And my theta, think about if you were on a unit circle, and if I was starting 0 here and going to here, how much am I going? I'm going pi over 2. So this would be 3 comma pi over 2, or because it's not saying whether we're in degrees or radians, we could say 3 comma 90 degrees. This is a little different. And then I'm going to show you an equation. So again, we have x equals 2, y equals negative 2. We have a point right here because these are rectangular. And if I were to draw my line here, I want to find out what this point is in r comma theta. Let's think about it for a second. I can find r pretty easily. If I were to make that into a triangle, and I know that the x length is 2 and the y length is negative 2, doesn't matter, we're squaring it, we can say that 2 squared plus negative 2 squared is equal to r squared, right? Pythagorean theorem. I have 4 plus 4, so 8 equals r squared. R equals the square root of 8, which is equal to 2 times the square root of 2. Now I know r. I have r comma theta, and now I know r is 2 times the square root of 2. And probably many of you could already figure out what theta is. I have a triangle. I know that this is 2 times the square root of 2. I know this is 2, negative 2, but it doesn't really matter for, I'm going to leave it positive 2 because all I care at the moment is about my reference angle. The easiest way to do it is I know that the tangent, let's call this theta. I know the tangent of theta is equal to the y over x, right? Which is 2 over 2, which is equal to 1. What angle theta gives me tangent of theta equals 1? That is theta equals pi over 4. Because it's sine over cosine, and sine and cosine are the same. So when I put the same value over the same value, I get 1. I know my theta is equal to pi over 4, but that's my reference angle. Actually, let me write it like that. That's my reference angle. Our point is actually in quadrant 4. So again, I could write it more than one way. I can say r is 2 times the square root of 2, and theta is minus pi over 4. Probably the easiest way to write it. Or 2 times the square root of 2. And I could say this is 7 pi over 4, because that's exactly the same point in quadrant 4. We've kind of seen a little bit of how we figure things out, right? Like I can use a Pythagorean theorem to get my radius, and I can use trig functions to get my theta. Why did I use tangent instead of sine or cosine? Well, I did it because if you have a point that's already in x, y, you already know y and x. If all I'm being asked for is the angle, I don't have to find the radius. let's just call this minus pi over 4, but we can see that there's two different solutions here. So x is -1 and y is negative the square root of 3. Square root of 3 is about 1.7. Our point is approximately right there. And we're looking for r comma theta. All we really need, because we know what we're doing, we're actually using our x squared plus y squared is equal to r squared. And that's how we're finding our radius, isn't it? Because we're just making, again, a triangle. Here we would have -1 squared plus negative the square root of 3 squared equals r squared. I have 1 plus 3 equals r squared, which makes r equal to 2. Pythagorean theorem, r equals 2. Theta, if I use my tangent of theta is equal to y over x, which is equal to negative the square root of 3 over -1. Again, I'm going to make both of these positive, and that's going to give me my reference angle. My reference angle is equal to the inverse tangent of the square root of 3 over 1. And I've said this a few times, so hopefully you understand what I'm saying here. I'm going to multiply both the top and the bottom by 1/2, which gives me the inverse tan of the square root of 3 over 2 over 1/2, which is the sine over the cosine. This, where the sine is the square root of 3 over 2 and the cosine is 1/2, my theta, my reference angle, is going to be pi over 3. And then all I have to do is take that reference angle and put it in quadrant 3. So we have theta is equal to pi over 3 plus pi, which is equal to 4 pi over 3. What's my r theta? R theta is 2 comma 4 pi over 3. That's my polar coordinate. Here we actually have the formulas, but we've already figured out the formulas. We already said we're going to use the Pythagorean formula for our r, and we said we're going to use our tangent. Or another way to say that is we're going to say, and honestly, I really think you should make everything positive and use your reference angle. I could say that the reference angle is equal to the inverse tangent of the absolute value of y over x. Now we want to convert from polar to rectangular. So I'm given something in polar and I want to change it to rectangular. These two formulas, where do they come from? You already know these formulas. For example, if I drew a triangle and I call this theta, and I call this x, and I call this y, and I call this r, if I want the cosine of theta, it's going to be adjacent over hypotenuse, which is the same as x over r. Multiply both sides by r, and I get r cosine theta is equal to x. That's my first one. And if I wanted sine of theta, it would be opposite over hypotenuse, which is y over r. If I multiply both sides by r, I get r sine theta is equal to y. So now if I have something already, if I'm given polar, I'm given r, I'm given theta, I can find x or y. So here, convert from polar to rectangular form, And this says round to 1 decimal place as needed. I don't think I need decimal places here because I don't think I need a calculator for these. So we're not gonna use a calculator. I want rectangular. So this is polar, and I want rectangular. X is equal to r cosine theta. R is 12. Theta is 5 pi over 3. This is equal to the cosine of 5 pi over 3. Again, reference angle pi over 3. That makes cosine 1/2. That's in quadrant 4. So I have this equals 12 times, in quadrant 4, cosine or x is positive. I know x is 6. And if I want to find y, it's equal to r sine theta, which is equal to 12 times the sine of 5 pi over 3, which is equal 12 times, and now again, this is in quadrant 4, and in quadrant 4, the y value is negative, and it's negative the square root of 3 over 2. So I get negative 6 times the square root of 3. If I want to find my xy for this r theta, it would be 6 comma negative 6 times the square root of 3. Let's do b. And I know that x is equal to r cosine theta, which is equal to 6 times the cosine 240 degrees. So 240 degrees is greater than 180, less than 270. So it is going to be in quadrant 3. My reference angle is 240 minus 180, which is 60. So our reference angle is 60 degrees. Both sine and cosine are negative in quadrant 3, so everything's going to be negative. And my reference angle 60, cosine of 60 is 1/2. I get 6 times negative 1/2, which is equal to negative 3. And then for y, I get r sine of theta, which is equal to 6 sine of 240 degrees. I know it's going to be a negative value. The reference angle for 60 degrees for the y value is the square root of 3 over 2. So I get negative 3 times the square root of 3. My answer to this in rectangular, x comma y, is going to equal negative 3 comma negative 3 times the square root of 3.